Yeah, bodies. Hello. Okay, they are down joining. Adwa. Adwa.
Yeah.
Is it better?
Yes, please.
Okay. Okay, so so I gave you 5 vectors acting at a point. This has a magnitude of 15.0 Newton, acting at 60 degrees to the x-axis. Then 19 acting along the x-axis, 19.0 Newton. Let me see the number. Okay, I have 11. Then we have 22 Newton acting along the negative y-axis. Then 16 Newton, 45 acting at the 45 degrees. Then lastly, we have 11 at an angle of 30 degrees to the x-axis. Right, so 1, 2, 3, 4, 5. Now the question demands that we find the magnitude and direction of the resultant. So as we've been doing.
Mr. Dia.
Hello. Pardon?
Please, will you send us the recording?
Yes, I'll do so. I'll
Okay.
send the recording onto the platform. But that's not to say that you are going to sleep. Okay.
Oh no, please. Brittany says she's in church,
Okay,
so I should record it for that.
I will. So
Okay.
let's pick them one after the other. F1, F2, F3. The magnitude of this is 11. 11.0 Newton. And this is F3. F4. The magnitude of F4 is 16. F4. And so
the 11 Newtons F4.
come again.
Is this the 11 Newtons F4?
Let me I'm rechecking. So I have 15 F, what I have labeled at F1, F2 19, F3 22. Oh, okay. Oh, this is F4. And this is F5. Good. It means you can see mistakes. So let's resolve them one by one. F1, okay, would be equal to 15 cos 60, then 15 sine 60 to the x-axis, right? Let's quickly evaluate this. What is cos 60 is half, right? So this is 7.5 Newton. Then sine 60 is √3 on 2. So 7.5 √3 Newton for the x. And because they are all within the first quadrant, positive, F2. Where is F2? F2 is along the x-axis or the horizontal axis. So it has a horizontal component and 0 vertical component. All right. So this 19.0 Newton as against 0. F3. F3 is also along the vertical axis. So it has 0 horizontal and then 22 vertical. But because along the negative y-axis, the y becomes a negative. So 0 minus 22 Newton. I hope you are with me.
Yes, please.
Okay, so F4. F4 30. So look to the x-axis. So 11 cos 30, 11 sine 30, which will be minus because it's within the third quadrant. F5. Okay, let's evaluate it. Cos 30 is root 3 on 2. So minus 5.5 root 3 Newton. Sine 30 is half. So minus 5.5 Newton. Then lastly, F5. F5, 16, 45 degrees to the x-axis. So 16 cos 45 degrees, which is a negative, and then 16 sine 45 degrees, which will be a positive. All right. So cos 45 is root 2 on 2. So minus 8 root 2. Then this will be 8 root 2, which will be a positive. But please give me these values in decimals, because at the end of it, you are going to sum everything up. So let's have them in decimals. Let's start from F1. F1, yes, the x will still be 7.5. Give me the y in decimals. 7.5 root 2. Are we there?
Please, 10.606.
Come again.
10.606.
So 10.666. So 67. Is that correct?
No, 10.606.
Okay, let me also confirm. I have my Adame calculator here. So 7.5 root of 3.
Hey, Mr. Day, I said root of 3. Sorry. This is 12 point.
So approximately 13.
Yes, please.
Please, when you are punching, inputting something, open your eyes, okay? The least mistake will floor you. Then 5.5 times root of 3. So 5 minus or 5.5 times root 3. That is equal to negative 9.53. Let me adjust there. Negative 9.53. And this is minus 5.5. Okay, let's look at 8 root 2. 8 times root of 2. This is 11 points. So negative 11.31. And so this will be 11.31 positive. All is well. Nana Jemfua Kofala, now Dromo. I wish I could mention the names.
Yes, please, all is well.
Okay. So let's then look for summation f of x. Summation f of x, we pick 7.5. Then this is 0. Okay, plus 19 plus 0 minus 9.53 minus 11.31. So give me the final answer for this summation. I'm also doing it. So 7.5 plus 19 minus 9.53 minus 11.31. Please, what did you get? Yes.
5.66.
Good. So 5.66 Newton. Summation f of y. Here we have 13. 13, we have 0 plus another 0. Hey, sorry. Sure. Minus 22 for F3, F4 minus 5.5, F5 plus 11.31. Okay, sum it up for me.
Please. Negative 3.19.
Please, negative 2.19.
Good. So minus 3.19 Newton. So beautiful. So after getting x and y's, let's draw them. Our x is a positive, meaning it will be along this. So we have summation f of x, which is 5.66 Newton. Our y is a negative, meaning it will be along this. So this is summation f of y, 3.19. Let me draw it well. 3.19 Newton, meaning it will be here. So that would clearly give us the magnitude and then the direction. So if this is here, equal vectors. So this direction plus this direction, then clearly the resultant will be here. So F resultant. Because this is perpendicular to this, just as this is, we'll use Pythagoras theorem. Theta becomes the direction of the resultant. Therefore, F r squared is equal to summation of fx squared plus summation of fy squared. So this is the square root of 5.66 squared plus 3.19 squared. Put them together for me. I'm also marking you closely with my calculator.
Mr. Jia,
Hello.
please, I have 6.49.
So approximately 6.5,
Yes, please.
right?
Yes, please.
Approximately 6.5. I want to check the answer from the book. Yes, that's the answer in the book. So we have square root of 42.2. Let me adjust the screen a little bit. So the resultant is equal to 6.5 Newton. And that's the answer of, in the book. Let's look at the direction. Direction of the resultant. Here we use this side of the board. And this is the angle it makes with the x-axis. So let's find that angle theta. There's the resultant. So let's determine this angle theta. Here, if we use tan of theta, which is equal to summation f of y on summation f of x. And summation y is equal to 3.19 over 5.66. Therefore, theta will be equal to the tan inverse of this.
Yeah.
Hello.
This wasn't the summation of Fy negative.
Yes, it's a negative. It is.
Then you've not written negative
Good.
up there.
You don't have to write. And this is the reason. And therefore, how do we come to the realization that summation f of y will be downwards, will be along the negative y-axis? Because we got a negative. Is that okay?
Yes, please.
Yes, please.
Because we got a negative, that's why we came to the realization that it will be here. And so this takes care of the direction, so you don't have to repeat it.
Yes, please. Okay.
All right. So what did you get for the angle? 3.19 divided by 5.66. There is it. So shift tan inverse of my answer gives me, it's giving me weird value. 3.19 divided by 5.66. So tan inverse of what I got. You know what? You know the problem I am.
Mr. Jia, please, I can't see the screen.
Hey, Deborah.
Mr. Jia, me too.
Mr. Jia.
Oh, then please rejoin. Let's see. Okay, it may be, yes. I know it's a natural problem, but since it's not a general situation, rejoin, right?
Mr. Jia, me too.
Please rejoin. Rejoin, let's see. You see, the problem I'm also encountering is that if you are determining angle and your calculator angular measurement is on radian R, you see rad on your screen. If you don't change it to DEG, DEG, it will give you different answers. Please, are you with me? If you don't change your calculator angular measurement from radian or gradient to degree, you get different answer. Whilst I input, that's the problem I saw. I realized that my calculator angular measurement was on rad. So I have to quickly change it from rad to deg, which is degree. All right. When we start circular motion, you realize that there are other angular measurements, such as radian and gradient. So I've set my calculator to degree. So 3.19 divided by 5.66, which is this. Then I take the tan inverse of this answer, and that's equal to 29. So I have theta to be equal to 29 degrees. Please, is that what you got?
Yes, please.
Good. So what it means is that the direction of the resultant from the x-axis is this. Okay. In case the question demands that, calculate it from, determine the direction of the resultant from y-axis, from the y-axis, then it means I have to measure the direction from y. And so I have to turn this way to face the resultant. So here, from the y-axis, direction will be 29 plus 90. So from the y-axis, the direction will be 29 plus 90, which will give me 119. 119 from the y-axis. But from the x-axis, the resultant is 29 degrees. So whichever way you go, you are not wrong. Please, is that okay?
Yes, please.
Akovala, your hand is raised.
Yes, please. Mr. Dab, please, I've gone over my work again. But when I left the resolutions of the vectors as an summation y, I left it in the third form, but I did not get the same answer as what we got.
You left it in a what?
The set.
Oh, okay. I think so. Next time, because at the end of it, you sum them up, and you can add irrational terms to rational terms. The sets are the irrational, so you have to convert them to decimal, which will be okay. Is that okay?
Okay. Yes. So this is a rule that we shouldn't add rational and irrational numbers.
You can't add them. How can you add maybe 1 to root 3? The best you can say is 1 plus root 3, but what is it? Is that okay?
Yes, please.
So next time, quickly change it to decimal and you'll be wobbling and hobbling. All right, so this is the solution to that brain twerking question I gave. Now, yes. Oh, yes, it's actually brain twerking. The question is actually brain twerking because you see, where you have so many forces acting at a point. Deborah, your hand is up.
Mr.
Hey, Deborah, you are not talking. Oh, please, do I clean the board?
Yes, please. Oh, please.
Hey, I'm
Please.
Mr.
Deborah, I can't hear you. Sorry.
Dear.
Uh-huh.
Hey, right? Yes. Oh, what?
Deborah, I'm listening now.
Mr. Dear.
Yes.
Mr. Dear, please you see the font. Looking at F2, look to if you are doing it and you add them together as one vector.
F2.
Oh God.
Yeah, your line is bad. Your line is bad. Okay, Deborah, send it to me via WhatsApp. Or yes. So I
Mr. Dua, please, the network is so good.
yes, it's a global challenge. I have it. In fact, I was really flogged. The network really shipped me today. It's a national cake.
Mr. Dua, please, can I have a screenshot?
Of this
Yes, please.
right now because
Yes, please. I can't see the board.
who is talking?
Me. I mean,
I'll send the video. Okay, I'll send the video.
yes.
Yes, to the platform so you can download. Okay. All right. Can I clean the board now?
Yes. Yes, please.
For the network. Even this, I've been somebody is singing. I ban you from singing. Last time. Okay. Let me give another trial. Then we look at solving questions on relative velocity. Okay. I'll fix another day for this morning session, which we missed. I think it will certainly be within the weekend. So we can make up and then move on. All right.
Okay.
Another trial on vectors. Good. I'm reading. Please put it into writing for me. 3 vectors P, Q, and R. Okay, let me write.
Please.
I'm writing. I think because of network problem, the writing will be better. So this is the problem of the evening. 3 vectors, P, Q, and R, are 3 units due south, 4 units southwest, due southwest, and 5 units due east. Find by calculation the magnitude and direction of A, P plus Q, B, P plus Q plus R, and C, P plus Q minus 2R. So this is the problem of the day. Start work. I want to see how you can think through before I come in. All right.
Okay.
Whoever gets it right will be awarded when school reopens.
Please, sir.
Whoever gets it right will be awarded when school reopens. But I think I'm giving you 10 minutes for this. All right, 10 minutes. So it's 7:50. So at exactly 8 o'clock, you are stopping work. So please work so fast and then, go with the time. Are we on?
Yes.
Okay. Is it challenging? Is it a challenging question?
It's a bit.
No, please.
Okay. So you do it. When you finish, we'll go through it. So you can assess whatever you were able to put down. You have 6 minutes more. 6. One minute.